Hello viewers, welcome. Now in this video we're going to derive the formula for an ideal gas density or the density for an ideal gas. We are also going to determine its units. So stay with me and see how simple it is. Now this is driven from the ideal gas law equation, which is PV is equal to nRT, where in this equation we are saying where the P is pressure. This is gas pressure. The V is volume. So V is volume. Then we have N. Our N is number of moles. So we have that for number of moles. We have our R. Our R is the ideal gas constant. Ideal gas constant. And T is Kelvin temperature. So this is Kelvin temperature or temperature in kelvins. So that's what we have in our formula there, the ideal gas law equation. PV is equal to nRT. Now, let's start our driving. We have PV is equal to nRT. PV is equal to nRT. Now, the first step is we are going to, now we not say our PV will be equal to, we understand to say the number of moles can be gotten by dividing the mass. Number of moles is equal to mass of a component divided by its molar mass, where M represents mass and the capital M represents molar mass. So this is what we are going to replace where we have N there. So instead of writing N, write mass over molar mass. So we'll have our mass here divided by molar mass, and this will multiply by RT. After doing that, we're going to cross multiply. When we cross multiply, we are going to have our PV M is equal to mRT. After doing this, we're going to divide by volume. When we divide by volume, we're going to have our P M is equal to mRT, that is divided by volume. Now, if we write this one, we say PM is equal to, we isolate M and V and then multiply it by RT. You find that what we have here is mass density, because mass density is given by density is equal to mass over volume. So this is what we are going to replace where we have mass over volume. We replace it by density. So we'll say we have P M, which is equal to, where there is mass over volume, we'll put density there, and this will multiply by RT. Yes. After that, all we have to do is, our job is done. All we have to do is just make density the subject of the formula. Doing that, we'll have our density to be equal to pressure multiplied by the molar mass, and this will be divided by RT. So this is the formula that we can use to find the density of an ideal gas. If we have our pressure, we have our temperature, we can find the density of an ideal gas. R is a constant and M is molar mass, which when we are given the gas, we can basically know its molar mass or determine its molar mass using the periodic table. So this formula will help us find density of an ideal gas. Now let's determine its units. What we have here is density is equal to the pressure in the units of atm multiplied by the molar mass in the units of grams per mole. And this is divided by the ideal gas constant. This has got the units of liters, atm mole Kelvin. And temperature, this will multiply by the units of what? Kelvins. So this is what we basically have here. We have ATM multiplied by grams per mole divided by liters by ATM per mole per Kelvin multiplied by Kelvins. Now from here, already we can see down here, this and that is cancelling itself. This is on top, this is down here, so those can cancel. Basically, what will remain here is we have, say this is equal to, we're going to have our ATM on top there, multiplied by grams per mole there, then divided by that. So we're going to say this whole thing here is divided by liters. Let me get rid of this part. Divided by what we have down here. What we have down there is liters multiplied by ATM. That is divided by the unit of moles. Yes. So we have the unit of moles there that are dividing. This and that has cancelled. We have liters by ATM per mole, which is what we have here. Now, ATM multiplied by grams per mole. We're going to change our sign here to the multiplication sign, and we're going to switch what we have there. So we have our moles on top there. This will divide by liters multiplying by ATM. When we reach this stage, it means our job is done. You see that moles and moles are cancelling, ATM and ATM are cancelling. The units that we are going to remain with are grams per liter. So finally, our units are grams per liter. So this is the units that we have for density of an ideal gas, grams per liter. Thank you. If you found this video interesting and helpful, please don't forget to subscribe to our channel and also invite your friends to do the same.